When we try to imagine large dinosaurs, it's hard not to include the T-Rex and Spinosaurus. Both were among the largest carnivorous dinosaurs, roughly the same size as an African elephant. But in terms of body size, they were nothing compared to the group of dinosaurs known as sauropods, the largest animals to ever walk the earth. Some of them, like the Argentinosaurus, which lived in Patagonia, Argentina, during the late Cretaceous period, could reach heights of 37 meters and weigh more than a Boeing 737 airplane. So, what allowed these dinosaurs to grow so massive? Let's explore this together. The Age of Reptiles. Dinosaurs are a group of reptiles that lived on Earth for hundreds of millions of years, from the Triassic to the Cretaceous period. The Age of Reptiles is a term that describes the animal population on Earth at that time, dominated by reptiles of various sizes. Some were bird-like, while others were much larger than giraffes or elephants, filling every niche on our planet, with populations continuously growing. Currently, about 700 dinosaur species have been identified, with carnivorous dinosaurs making up 40% and herbivores dominating the rest. Early dinosaurs and evolution. During the Triassic period, a subgroup of animals from the archosaurs first appeared. Desmatosuchus was an ancient plant-eating reptile described as having armor around its body. This type of formidable appearance would later be commonly seen in dinosaurs during the Mesozoic period. Even in the trees, there were strange creatures like Trypanosaurus with humps, curved claws, and hooked tails. What was once empty was now dominated by flying reptiles from the pterosaur group. Coelophysis, Parasaurus, and Eoraptor were some of the early dinosaurs that lived at that time, before larger, long-necked dinosaurs emerged. The Jurassic period, a green and abundant world. As Earth entered the Jurassic period, nature became greener and more abundant in natural resources. Dinosaurs began to establish their existence as the dominant species. Theropods, which were initially cat-sized, drastically transformed into terrifying monsters like Allosaurus and Ceratosaurus. Sauropod dinosaurs also appeared during this period, becoming the largest land creatures. Cretaceous period and gigantic growth. Amidst the lives of dinosaurs, by the Cretaceous period, some dinosaurs had fully evolved, with some capable of crushing prey bones with powerful bites. On the other hand, long-necked dinosaurs like Titanosaurus reached heights of 30 meters and weighed 66 tons. For a long time, researchers believed that the high oxygen content in the atmosphere during that era allowed dinosaurs to grow to larger sizes. This was based on findings of animals from the arthropod group, like Megafauna, which could grow large during the Carboniferous period, about 300 million years ago, before dinosaurs appeared. However, recent research indicates that oxygen concentrations in the atmosphere at that time were likely lower than they are today, refuting this hypothesis. The blue whale and aquatic advantage. This finding then led researchers to a new theory, focused on a specific group, the sauropods from the Mesozoic era to the present. No animal larger than a blue whale has ever been found in the ocean, whether dinosaurs, birds, or marine predators including mosasaurs, ichthyosaurs, and megalodon. An adult blue whale can grow up to 30 meters long and weigh up to 110 tons. In some cases, female blue whales, like one found in the Southern Ocean, Antarctica, in 1947, weighed twice as much as some of the largest dinosaurs ever discovered. All of this is possible because blue whales live in the ocean. The buoyancy in the water helps whales reduce the gravitational load on their bodies, so a portion of their body weight is supported by water, not entirely by muscle and bone. Thick blubber also helps them stay warm while serving as an energy reserve that contributes to buoyancy. This combination of water support and fat may allow whales to grow much larger than land animals, which must fully support their body weight against gravity. Land mammals versus dinosaurs. However, when we talk about the largest land animals, mammals are nothing compared to non-avian dinosaurs. For example, Patagodoton maorum, a plant-eating dinosaur discovered in Patagonia, Argentina, is estimated to have been about 36 meters long and weighed approximately 64 tons. In comparison, the largest known land mammal to date is from a hornless rhinoceros species, known as Paraceratherium. It weighed 15 tons and stood 5 meters tall, and once inhabited parts of Eurasia from Romania to China, long after the mass extinction of non-avian dinosaurs. The air sac system, a key adaptation. So, why did these two groups of animals end up with vastly different body sizes? This can be explained by a special organ found in dinosaurs' bodies that functions like a sophisticated air sac system. These sacs are essentially soft tissue pouches connected to the lungs, located in the body cavity, neck, back, and hips. They allowed dinosaur bones, despite their large size, to remain light without sacrificing strength as they moved. Researchers discovered this because their living relatives, birds, also have a similar air sac system. This system helps birds deliver air to their small lungs while making their skeletal structure feel very light. If we try to compare the respiratory system of birds with large dinosaurs, we will see striking similarities. For instance, in sauropod dinosaurs, the cervical and dorsal vertebrae have the same sacs and indentations as those found in birds today. Researchers could determine this because when paleontologists scanned fossils of some dinosaur bones, such as vertebrae, they often found empty spaces within the bones whose purpose was unknown, leading to inconsistencies. However, after researchers performed anatomical comparisons with birds, they found the missing link. Those empty spaces were where the air sacs used to be. It's important to note that not all extinct dinosaurs had these practical air sacs. Only the type of dinosaurs known as saurischians had them. This group of dinosaurs includes theropod and sauropod dinosaurs. Dinosaurs outside this group, such as duck-billed dinosaurs, armored dinosaurs, and horned dinosaurs, known as ornithischians, did not have these air sacs, which made them less flexible in movement. Furthermore, mammals, both past and present, do not have anything similar to these air sacs. They have a skeletal system with dense, heavy bones, which limits how large their body size can become. Therefore, what should be noted from this explanation is that it was this adaptation that allowed dinosaurs, especially the sauropod group, to become enormous. Natural selection and ecosystems. Different from the first theory, which focused on morphological details of dinosaur bodies, the second theory leans more towards natural selection. Jurassic sinensis is one of the oldest known placental mammals, living almost 65 million years after the appearance of the first mammals in the late Permian period. Mammals at that time were no more than small, mouse-sized animals that only came out at night to scavenge for food and insects. How could such small animals compete with dinosaurs that had diversified and reached body sizes never achieved by any other group of land vertebrates? Moreover, the breakup of the supercontinent Pangaea in the early Jurassic allowed dinosaurs to establish ecosystems across all land masses worldwide. Ceratosaurus was a long-necked dinosaur only about 3 to 4 meters long and weighing approximately 200 kilograms, living in the early Jurassic period. Initially, their lives were threatened by the presence of larger theropod predators like Dilophosaurus. To survive the pressure from larger predators, long-necked dinosaurs began to evolve to larger sizes. A large body could intimidate predators and also made it easier for them to eat plants that were initially out of reach. This environmental pressure resulted in giant land animals like Cetiosaurus during the Jurassic period, which could reach lengths of 16 meters. Diplodocus, in the late Jurassic period, evolved to have a more horizontal and slender body. Other sauropods, like Sauroposeidon, developed necks that were longer than their tails, reaching 18 meters high. And as these herbivorous dinosaurs grew larger and began to appear in North America, China, and West Africa, carnivorous dinosaurs also evolved to keep pace, generally for prey. Some carnivorous dinosaurs that participated in this chain of events successfully evolved to match the size of the sauropods, such as Megalosaurus, which was 9 meters long. Only after dinosaurs experienced a mass extinction due to a meteor impact did mammals begin to dominate our planet, as seen with Paraceratherium, crowned as the largest land mammal.